Hello everyone, this is Hitesh and Vineet and Ayush is here, and today we will be demonstrating our mini project which is on the title of Topic Identification System. So let us have a look at the outlines of our presentation. So first I will be introducing about my project, then we will be talking about the dataset that we have used in our project, moving on to the libraries that we have imported for the implementation of our project. And after that, I will be explaining the implementation part of our project. And at last, I will be telling some real life application of our project. So let us first understand the topic identification system. This system is designed to analyze large volume of text and identifies the main topics or subjects. For example, headlines in the news articles or the titles of the blogs are the best example of the topic identification system because topic identification system will create such titles or headlines that will seek the attentions of the users or the people who read the newspapers, and that is where the users, by reading the headlines or the title of the blogs, are going to definitely read those news or the blogs, and that is where the topic identification comes into the picture. So moving on to the data set, we have downloaded our dataset from sklearn library, and it basically consists of 20,000 news group document which are basically categorized into four categories, which are politics, sports, religion, and technology. So this dataset basically consists of only these four categories, and whatever be the document or the paragraph that will be containing in this dataset will only talk about these categories. So moving on to the imported libraries, we would be having a number of libraries in our project, but these four main libraries are the core part of our project. So let us have a look at them. So the first one is the GenSim library. So we are basically importing stop words and pre-processing module from GenSim library. So stop words are basically the punctuation marks or the jargons. So which are basically like underscore, commas, full stop. We need to remove these words, and along with that, what we are doing in pre-processing, we are basically removing the conjunctions or the prepositions from our sentences or the paragraphs that we are having. So if the length of the words is less than 3, then we are basically removing them from our pre-processed data. Moving on to the NLTK library, we are basically importing WordNet Lematizer or Snowball Stammer module. The functionality of both the modules are similar. What it does is that it takes the words and convert them into the root or the base word. For example, running into run, walking into walk. And this is basically the functionality of the NLTK library in our project. Moving on to the sklearn library, we have downloaded our dataset from the sklearn library itself. And the last one is the NumPy library. So it is basically used to perform the mathematical operations on array, list, or vectors. So moving on to the steps and the flow diagram of our project. So the first one is the research and the business understanding. So let us first understand the problem statement of our project. So we will be having a paragraph or document, and those paragraph or document is basically talking about the key elements in that paragraph, and we need to predict that topic or the element of the paragraph, and that is what the problem statement of our project. Moving on to the data preprocessing, as I have already explained that we are importing GenSim library for importing stop word module as well as the preprocessing, in which what we are doing is we are basically removing the words whose length is basically less than 3. Moving on to the lemmatization and tokenization. So what we are basically doing in that is we are basically converting the words into the root word or the base words, like running into the run, walking into the walk. After that, we are creating a dictionary. So what we are basically doing in a dictionary, we are taking each word and assign a unique ID and storing into in the form of the dictionary, like a key and a value pair, where key is a unique ID and a value is a word. After that, we are creating a bag of a word. The bag of a word representation of each document is stored as a list where word ID, comma word count are the basically format of storing the bag of word. But before we are storing the words into the bag of our words, we are basically filtering them. And we are filtering them on the basis of three parameters, that is number of below, number of above, and keep n. So what this filtering is does is that the words that occur in less than number of below documents, word that occur in more than number of above of all documents, and the dictionary is restricted to only keep the top k and most frequent tokens. After that, we are basically creating the bag of our words, which will store the word ID and the number of a time each word is appearing in our document. And after that, we are basically creating an LDA model, which is an unsupervised machine learning algorithm, and we will be passing number of a parameters such as number of topics, the number of topic that we want to predict from our model, and the parameter such as passes, which controls the number of times the module will iterate over the corpus during training, and the workers, which controls the number of worker threads to use during the training. So this is all about the implementation of our project. Let us have a look at the programming sections of our project. So we will be having a paragraph or a document, and we need to predict the topic for that paragraph or the document. For example, let's say we are having this paragraph, and the topic for this paragraph is hiking in the mountains during the fall season. So coming to the dataset, we have downloaded our dataset from the sklearn library, and the name of our dataset is fetch20 news group, and we have divided our dataset into training and testing subsets, and we have done the shuffling so that the ordering bias will not come into the picture. After that, we have imported some libraries. For example, we have imported the Jemson library for importing the simple preprocesses module. What does it? The basic function of the simple preprocess is to tokenize the text and converting it to the lower cases. After that, we have importing the stop word, which is basically a module of the common English words that are often filtered out during the test preprocessing. Coming to the NLTK libraries, which are the natural language toolkit. So for them, we have imported the word net lematizer and snowball stammer, which are basically which the function of them is basically to convert a word into a base word or the root word. For example, if we are having a word like running, so it would convert them into the run. Going will be converted into the go. After that, what we have done is that we have downloaded a dataset named as WordNet, which is a collection of a large lexical database for the English language that provide access to the WordNet SysNet and relationships. After that, we have defined two functions. The first one is the lemmatized stemming, and the second one is the pre-processing texting. So I've already explained you the about the lemmatization. So what it does is this: it takes the words and converting into the base word, and we are taken all the words as a verb. So this V is representing basically the verb, and we would be returning the base word. And if we talk about the pre-processing, then what we are doing is that we are iterating over the text, and if the stop words are coming, then we are ignoring it. And also that if the length of the word is greater than 3, then only we are considering it. Otherwise, we are just ignoring all the words. After that, let us for understanding what the lemmatization and the pre-processing function is doing, we have taken an example like Sarah did not like to read. She was not very good at it. So after performing the lemmatization and pre-processing, the words that we would be having is Sara, like, read, and good. And after that, what we are doing is we are basically iterate. We have done the same pre-processing and lemmatization on all the documents. So for we are printing the corresponding pre-processed data for the two documents. So these are the output of the first two documents. After that, we are creating a dictionary which takes a list of pre-processed document as input and create a dictionary object that map each unique word in the corpus to a unique integer ID. And the resulting dictionary object can be used for a variety of a task, including the topic modeling. And for the sake of the verification, we have also printed what the dictionary is actually containing. So we have printed a few items from the dictionary to get an idea how the words in the corpus are being represented as an integer ID. After that, we are just filtering on the dictionary. So there are three parameters: number below, number above, and keep n. So what it does is actually it removes words that occur in less than 15 documents, words that occur in more than 10% of all the documents, and dictionary which is restricted to keep only top 1 lakh most frequent tokens. Then coming to the resulting of the bow corpus, which is a bag of words, it's basically in bag of word each element in the list representation one of the preprocessed document in the original preprocessed doc. After that, what we are doing, we are just iterating over the bag of words, which is a list of a word ID and word count tuples representing the document bag of word representation. For each tuple, what we are doing is that we are printing the word integer ID corresponding the word string obtained from the dictionary using that ID and the frequency of the word in the document. As you can see in the word, this is the word number along with that corresponding word and the frequency, how many times it appears in the document. After that, we are defining an LDA model, which is an unsupervised machine learning algorithm that can automatically identify the topic present in a collection of a document. After that, what we are doing is that the number of parameter are the bow corpus, which is a bag of word corpus. Number of topic is 8. I2 word, basically to associate each word with a frequency. We have taken ID2 word. Then the passes argument controls the number of times the model will iterate over the corpus during the training, and the worker argument controls the number of worker thread to use during the training. So the output will be considered in such a format like if a sentence or a paragraph is consist a word like Christian, Jesus, moral, religion, and church, then the corresponding weights will become 1, and the and non-existing word will become 0, and then we will be taking the sum of this particular topic. So whosoever topic will be having the highest weight will be considered as the topic of that paragraph. So let us have a look at the real life application of topic identification system. So the first one is recommendation system. So what it does is that it basically helps to identify the main topics or themes in a user generated content, such as product reviews or social media posts. For example, on any social media platform such as a Facebook or Twitter, when a user tweets or put a post of it, so what it does is that it basically categorizes each post into a particular categories such as a brand or the clothing items. So what it does is that when another user searches for a particular post or a brand of clothing, such as a particular brand, so it will show the results by showing those tweets or those number of posts or pictures that another user has put on the social media post. The second one is the search engine optimization. So it basically help in optimizing website and content to rank higher in search engine result pages. So the basic example of this application is that whenever we search anything on the Google, the result that we get is particularly in a particular order, and those order is done only by the topic identification system. The website or the result matching with most that is matching most with a particular topic will be provide the number one precedence and so on. And that is where the topic identification comes into the picture. And the last one is social media monitoring. It helps tracking and analyzing social media activity to gather insights and inform decision making. So that was all for our project.